right, good morning, everybody, and welcome to another exciting Exploring by the Seat of Your Pants broadcast with us here. My name is Jesse. I know we've got a lot of familiar faces in the crowd, and so you will know that we are all about bringing conservation, adventure, and science into classrooms around the world. Now, in this job, I have the privilege of getting to work with some of the coolest, most amazing people on this planet. It's such an honor to get to bring them to you every single week to feature their incredible stories of science and exploration from around the globe and beyond. But today I'm particularly excited because it's early morning, bleary-eyed in California. We are joined by Dr. Abigail Fraeman, and she is the Deputy Project Scientist for the NASA Mars MSL mission. Oh, that's the wrong button. I got all the banners up to bring up. There's too many Mars things. MSL mission, we're going to learn a little bit about her amazing work to understand and explore our neighbor in the sky, Mars. It's so incredible to me that we get to explore other planets with robots, with probes, with fancy new helicopter on our latest mission to Mars. It's a really, really exciting time to be interested in space. In fact, I would say it's the best time ever to be interested in space. There's so many missions on the go. There's so much potential for the future, and there's so much happening right now. So without further ado, I'm going to welcome in Dr. Abby. She's going to blow your mind about Mars, and then I am going to dive in with a Kahoot, which I will feature again the game pin at the end, and we are going to take all your questions you ever want to know about exploring the Red Planet. Dr. Abby, thank you so much for joining us again. Welcome in and good morning.
Oh, thank you. It's my pleasure. I'm so excited to be here with you today.
Well, I know you've got a lot to share with us, and I want to dive in with this incredible picture you have on your first slide to get started. So I will leave you to it, and I can't wait to dive in.
Fantastic. Well, wonderful. Hello, everybody. My name is Dr. Abby, and I'm here to tell you a little bit about my life and my job exploring Mars. So I'm talking to you today from my office, which is in California, right outside of Los Angeles in a town called Pasadena. We're on the west coast of the United States. And I work at a place called the Jet Propulsion Laboratory, or sometimes we like to call it JPL, which is one of several NASA centers all around the United States. NASA isn't just one single place. It's actually a whole bunch of different places. Some parts of NASA specialize in astronauts and human exploration. So that's like the NASA Center in Houston. You may know the famous phrase, Houston, we've had a problem. Or there's a NASA center in a place called Florida. That's where they do a lot of the shuttle launches and the rocket launches. But the NASA center I work at out in California specializes in robotic exploration of the solar system. So going to places and learning about places that we can't go ourselves as humans, but we are able to send our robotic explorer companions. Even though my office is in that building right there, kind of nestled in the foothill of what are now snowy mountains, which is very strange for California. My other office is on Mars, which is our neighboring planet. It's the fourth planet from the sun. It's often called the red planet, which you can probably tell why looking at this picture. The whole planet has kind of rusted. There's a lot of iron, and all the iron is oxidized. But I love exploring Mars and making this my second office because I think it has the potential to teach us a lot of really important things about ourselves and about our place in the universe. One of the questions that we're hoping to answer Mars, I think, is the biggest question that you can possibly ask, which is, are we alone? Is Earth the only place in the universe that has life? Or are there other worlds with other kinds of life on it, either in our own solar system or outside? Now, Mars today, we know, probably doesn't have life. The planet is very, very cold. It's very, very dry. But we think billions and billions of years ago, Mars was actually a lot more Earth-like. We think Mars had a lot more water. Maybe it looked a little bit more like the blue planet, which is Earth. It probably had a thicker atmosphere. Maybe it was even a breathable atmosphere. And it was probably a lot warmer. And this was about the time that we think life originated on Earth. So a big question we're trying to answer is were the conditions on the two planets really similar? And if so, is there a possibility that the same process that started life on Earth also happened on Mars? If we find out the answer is yes, That's going to be so profound because it would tell us that life started 2 places in our solar system independently. And then if you extrapolate that out to just the thousands of planets that we know exist now, the odds of that same process happening on at least one of these other planets, and probably hundreds of them, just become astronomical. So we don't know if there was life on Mars yet, but we have really good reason to think there may have been, and we have really good reason to keep looking. I also think Mars is fascinating to study, even if we don't find life, because it will help us understand what drives planets to make them good places to live. In our own solar system, these are the 4 most inner planets. We have Mercury, Venus, Earth, and Mars. And Earth, it's kind of like Goldilocks and the 3 bears. Earth is just right, but something happened that made Venus way too hot for life, and something happened that made Mars way too cold for life. And we'd like to understand what it was that kind of drove these entire planetary systems to make it so that Earth was just right, but Venus and Mars were not. And again, we're going to be able to, when we figure that out, extrapolate that out to these thousands of planets that we now know exist outside our own solar system. And it will help us try to find the ones that probably evolved most like Earth and would be most likely to have planets that would have life. And then finally, I think one of the most exciting reasons to study Mars is the notion that one day we will actually be able to send humans to go study the rocks on Mars and explore this entirely new planet. Mars has a surface, it has a place that we can explore. And before we do that, we need to be able to understand the kind of challenges that humans would face when they land on Mars. What kind of radiation environment will they be exposed to? Mars's atmosphere is very thin. And, if you get a very bad sunburn, if you were out on the surface of Mars without some protective spacesuit, you'd also want to understand what kind of temperatures you might find. What would the weather on Mars be like? How would you protect yourself from that? What kind of resources might actually be on the planet that you yourself could use? In particular, where might you find, say, water ice that you could drink when you were there, maybe living out for a couple of years as you explore? And so we're laying the groundwork now. So hopefully one day, and maybe this would be one day when you guys are just about the age to be astronauts, humans will walk and explore the surface of Mars. Now, to answer all of these questions, we can use the tools of geology, which is the science of studying the rocks and learning how they formed and the history they preserve. On Earth, we can do geology in Mars-like places like the volcanoes in Hawaii or Iceland, or the really dry environments of the desert. And so here's pictures of me in these Mars-like places, and I have tools that a geologist have. There's a picture of me with my hand lens out, looking at the rocks really close. I can bring my rock hammer out and chip away pieces of rocks and then bring them back to the laboratory to use the instruments here to study them. But on Mars, we don't have this advantage yet. We don't have astronauts who can go and walk around with their own rock hammers and act like geologists do on Earth. So instead, we've sent a fleet of robotic explorers to look at the planet. And these come in 2 forms. They come in the form of satellites that we've sent that orbit the planet and collect data from above. And then they also come in the form of landers and rovers that we can actually send to the surface of the planet to drive around, to take pictures, to take measurements. And I'll note that this graphic is actually a couple years old, and you can see there's a whole lot of different spacecraft here representing what has explored Mars. I think this is actually even out of date now, and there's even more that we've sent to the surface. So I agree, this is a very exciting time to be exploring our solar system. There's so much going on. The orbiters are great tools for telling us about Mars. Here's an example of one of the pictures that an amazing camera sent back. This was a camera that's called HiRISE, and it can get to as high of a resolution as 25 centimeters per pixel. So at this resolution, you could see, for example, your car sitting on the surface of Mars. You could even probably see you if you were standing on the surface. We haven't seen any cars or people yet, but we can see things like these beautiful rock formations that form these really dramatic, they're called sedimentary rock layers. There was some process, wind or water, that laid down these rocks billions of years ago and formed these beautiful layers. Or we can see things like this, where we have these vast sand fields that are black. The sand on Mars is black because it's made up of broken bits of volcanic rock, dark black volcanic rock. And so there's these big sheets of black sand, and we see these beautiful ripples and scalloped figures that form when the thin Martian atmosphere blows the sand around and makes these beautiful designs. From orbit, we can also tell things about what the surface is made of. Now, you can probably guess that the colors here aren't actually the colors that we see on the surface of Mars. Instead, this is a very special kind of image where the colors actually represent the kind of minerals that we see forming from orbit, and each color represents a different mineral. And so these are the kind of minerals, some of them are minerals that you would find coming out of volcanoes. And some of them are minerals that only form when they interact with the presence of water. And that's a really exciting finding when we find minerals that form in the presence of water, because we know water is one of the many ingredients that life requires, at least here on Earth. Any form of life on Earth that we found needs at least some water to survive. So this tells us that there was water on Mars in the past, and specifically liquid water, not just water frozen in ice, which we know Mars has today, or a little bit of water in the atmosphere, but this was liquid water flowing on the surface of Mars. And in fact, this in particular was a very special image, because not only do we see minerals that formed in water, we can actually see the kind of structures that we know are caused by these watery processes. And so this is actually the rim of a big, it's called an impact crater, a big hole in the ground. And coming into it, there's this kind of snaky channel. This was actually probably once an ancient river. And when it came into the crater, you can see it makes this kind of weird kind of explosion shape. This is actually, we think, something called a delta, which forms when you had water coming from a river and depositing into a lake. So we think this was a crater that was once filled with a lake, and you had all these rivers coming into it and settling out. So this is a particularly exciting place to explore. And in fact, we were so excited by what we saw from this location. It's called Jezero Crater. So excited by what we saw from this location from orbit that we actually sent something to the surface to see what it looked like with our own eyes from the surface eye view. But before I get to that, I do want to tell you a little bit about the surface exploration of Mars. And that really began in the 1970s with a pair of landed spacecraft called Viking 1 and Viking 2. These two spacecraft just touched down onto the surface of the planet. They sat in a single spot, but they were our first glimpse as to what the surface of Mars looked like. It was this very red, very rocky place. Viking 1 and 2 did some great experiments, scooping up soil, looking for any evidence of life in the soil. They didn't really find anything that we're super confident about. But the geologists who were part of these teams saw images like this, and they thought, oh, this is amazing. But if only we could just walk over to those rocks and pick them up and look at them like we were as a geologist. And it was a little frustrating to be stuck in one spot. So 20 years later, NASA sent the next mission to the surface of Mars, and this was the PATHFINDER lander. And with it, they brought a little buddy, the SOJOURNER rover, which is, when you look carefully all among the dark rocks in this picture, you can see there's this tiny little rover on the surface of Mars. This is about the size of a microwave. And this was the first demonstration that not only could we land on Mars, but we had the ability and the technology to build things that could actually drive around on Mars and drive up to these rocks and look at them and understand what they're made of and tell us more about their history. So this was so exciting. But of course, the geologists, as they did with Viking, they saw this and they said, this is great, but I want more. And so they designed a pair of rovers that had a whole bunch of geological tools that would not only be able to drive, but would be able to do things like grind into the surface of the rock to see what it looks like under the surface, like you would chip a rock with a hammer, and they had a microscope. And these were two rovers. They built two that were identical, named Spirit and Opportunity, that landed on Mars in 2004. And this was the picture that Spirit originally sent back. It landed again on a very similar looking place to where Viking had landed, to where Pathfinder had landing, showing Mars was just sort of this rocky world, lots of dark rocks. But the hope was that Spirit would be able to look at these rocks and find real evidence, not just from orbit, but from the ground, that liquid water had once flowed on the surface of Mars. Now, I think this is a pretty cool picture. It's a beautiful view of the surface of Mars. But I have to say that of the two rovers, between Spirit and Opportunity, when Opportunity touched down, that just blew my mind. And so, we had been seeing pictures of Mars, like I just showed you, these rocky worlds, these dark black rocks sitting on this white surface. But when Opportunity landed and Opportunity sent the first image back down from Opportunity's landing site, this is what we saw. And this is just a completely different world. This is the same planet, but everything is different in Opportunity's landing site. There's no dark rock sitting on the surface. Instead, what you see is Opportunity landed actually in a very shallow crater. And so we're right in the middle of the crater, and looking out into the walls of the edge of the crater, there's this bright colored bedrock poking through. And to geologists, this is one of the most exciting places you can possibly be, because when you find bedrock, that means you found rock that has formed in the place that it is now. And it gives you a lot more context about the past environment. And in fact, when Opportunity eventually drove over to these rocks and looked at it with her scientific instruments, she found that these were rocks that were laid down in water. And this was the first evidence we'd ever had from the surface of Mars that Mars was once a watery world. And, I was telling you how important this image was to me. I actually, at the time Opportunity landed, I myself was a high school student. I was 16 years old. And I had an amazing opportunity to come out to be at NASA's Jet Propulsion Laboratory in the room with the science team. And I got to see as these images first came down, and there I am in the picture. And it's just blowing my mind to see this for the first time and seeing how excited the scientists were. And this kind of image was really what inspired me to want to get a job exploring Mars for my career. And to put that kind of in perspective, this might be a little bit hard to see here, but this is actually a map showing everywhere that Opportunity drove. Opportunity was only supposed to last for 90 days or 90 sols on Mars. We call a day a sol. But Opportunity just kept going and going and going and going, and ended up lasting for something like 14 years. And during that time, my career continued to go. So I was in high school all the way at the top of this traverse when Opportunity landed. I graduated high school. Opportunity was still going. I started college. I studied physics and geology in college. Graduated college. Then I started graduate school to study Earth and planetary science. When I was a graduate student, I became involved with Opportunity's mission because Opportunity was still going. And I actually got to be part of the science team helping to figure out where to drive the rover and what measurements to make. I earned my master's degree. Opportunity was still going. I earned my PhD. Opportunity was still going. I started something called a postdoc, which is a job you have for a couple years, usually after you get your PhD. Opportunity was still going. And eventually I got hired to start my dream job here at JPL, and Opportunity was still going. And I got really lucky and really excited to actually, as a JPL employee now, get appointed to get a role working on Opportunity in a position called Deputy Project Scientist. And I held that role for 3 years until the mission ended when a big dust storm knocked it out. So how exciting for me to not only get to work on a mission like the kind of mission that inspired me to explore Mars, but the exact same mission. And I'll just put a brief plug. If you want to learn more about spirit and opportunity, there's this fabulous documentary that just came out on Amazon Prime Video called Good Night Oppie. And it talks all about spirit and opportunity and the mission that both of those rovers had, what it took to build them, and then a lot about the team who built and operated them. And if you watch this, you might also see a familiar face. But what do I do now? Now that opportunity is not functioning anymore, I'm working on the next rover. And again, the scientists, opportunity was amazing, showed us we had one ingredient life needed, but we keep asking more. We want to learn more. And following that, we wanted to learn, okay, not only was there life, but were there the water, were the other ingredients that life need? Were there things like carbon containing molecules and sources of energy? And answering those questions requires much bigger science instruments. And so that led to Curiosity, the next Mars rover, much bigger, much more capable than Opportunity was. Curiosity landed in this big hole in the ground, big impact crater called Gale Crater. That was really exciting because in the middle of the crater, there's this big mountain of rock. And we can see from orbit that this mountain is layered. And so the idea was we would land at the base of the mountain and then climb this mountain and read the layers of the rocks as we climb to understand the changing environments on Mars and to understand if those would have been good for life. This was Curiosity's first view of the mountain when we landed. So this was our first color picture of Mars, I think just as extraordinary, if not more, than Opportunity's first picture of Mars. And right after we landed, we found that there were these rocks that had these rounded pebbles in them. And this was so exciting because right away we could see the rocks were the kind of rocks that you expect to form in rivers. So here's a rock on Mars with these rounded pebbles. And on the other side, this is the kind of rocks you find that form in rivers on Earth. So we landed in an ancient riverbed. And when we looked off to the side of the mountain, we could see all of these layers. And when we got close and we actually looked at the layers up close, we could see that they were made of very fine grained rocks. The layers were very, very parallel to each other. And these are the kind of rocks that you find that form in lakes. So we realized that this crater, at least early in its history, once had rivers flowing into it that then pooled and formed lakes. So we knew one of the ingredients of life was present in Gale Crater when we landed. And then using our tools and the big instruments inside the rover, we could actually very carefully measure the composition of the rocks. And this told us that those other ingredients were also present. Those carbon-containing molecules, they're called organic molecules, were present in these lake deposits. We found elements that could help power metabolisms of life. And I love this picture. These are all, we drill into the rocks and we collect little powder, and then we analyze that powder with the instruments inside of the body of the rover. But I love this picture because you can see that when we drill under the surface of Mars, we found Mars isn't necessarily the red planet at all. Underneath Mars is the gray planet and the brown planet and the purple planet and sometimes the red planet. But all of these different colors are because there's different minerals and different things that make up these rocks because they all formed in slightly different environments. Now we're very, very high on the mountain, and we found as evidence in the rocks that the lakes have dried up. Instead, there's these big sand dunes that were blowing around very dry environments, and we're driving through these very impressive buttes that were formed by ancient sand dunes. And, this is a beautiful image that the rover took. This just gives you to scale what it actually looked like on the ground. Here's a simulation of the rover. And these hills are huge, and there's so many cool rocks to look at in them to tell us about the history of Mars. And we find cool rocks that aren't Martian either. Here's something we found just a few weeks ago. This shiny rock is actually a meteorite. This is a rock from space that fell to the surface of Mars and really looked different. So we went over to investigate it. And right now we're actually investigating this layer very high on the mountain, past where we found all this evidence that Mars had dried out. And it's this dark shelf-like layer. But when we looked closely, we found these very interesting structures in the layer. And these are actually something called ripple marks. And again, on Earth, you have ripple marks like this form when you have very kind of shallow pools of water sloshing back and forth. So this has been so exciting. And it's told us that even though Mars dried up for a bit, there may have been pulses where it became wet again. And we were so excited. We wanted to sample these rocks. So we tried to drill them. We tried one time, it failed. We tried a second time, it failed. The rock was just breaking and it was too hard. So we tried a third time and that didn't work. We picked another rock. We tried a fourth time. And then finally, the fifth time we tried to collect a sample of this rock to investigate, it worked. So right now on Mars this morning, we are investigating the powder from this rock sample. We're very excited to finally get a sample. And it's going to tell us about what the conditions on Mars were like in this very strange, unusual interval during its history. So stay tuned to hear what we find. I can't wait. But this is just another spectacular view that we just took, and hopefully you can see it pan across a little bit. But this is the road ahead. This is where we will be driving in the coming years, and I just am so excited. There's so much to explore as we climb this mountain. We're stepping forward in Martian time, and we're seeing how the environment changed. I'll wrap up really quickly by just talking a little bit about where we're going, and that's the next step. As the theme is, the scientists, we just want more, we want more. And so there's so much we can do with these rovers on the surface, but really, we think to answer this question about whether there was ever life on Mars, we're going to need to bring rocks back to Earth to study in our laboratories. And to do that, we're doing a series of missions called Mars Sample Return. And so that starts with this curiosity-like looking rover named Perseverance. And Perseverance has a buddy of a helicopter that flies along with it. And Perseverance is collecting rock samples that we're eventually going to put on this big rocket and shoot off, where a satellite is going to catch them and then bring them back for us to study in our labs on Earth. And here's a picture of Perseverance shortly after it landed in just about 2 years ago, and Perseverance's helicopter buddy, Ingenuity. Here's an image of what those rock samples look like. This was one of the first core samples that Perseverance collected. They're kind of the size of a piece of chalk. And then just last month, Perseverance finished dropping the first 10 of these rocks on the surface, kind of leaving them on the surface so we can come back later, pick them up to bring them back, just in case something breaks on the rover. We want to make sure they're all set. So here's Perseverance looking down at one of those sample tubes that might come back to the laboratory one day. Maybe one of you will study this rock if you want to go into science and study Mars. And I'll just wrap up. If you want to keep learning about Curiosity, about Perseverance, about all of NASA's exploration with Mars, you can do that at this website, mars.nasa.gov. We post updates almost daily about what we're doing with Curiosity. Perseverance has a blog as well, and there's just lots of resources and images that you can see. So with that, thank you so much for your attention, and I'm happy to take any questions.
Oh, Abby, that was extraordinary as always. The view of what Curiosity is going to go to next is like literally and figuratively like unearthly beauty. Like, it's just unbelievable to think that's something that we're going to explore and that kids can check it out. I've pulled this up before the broadcast today, but literally the Where is Curiosity, and you can follow its entire journey and just see the whole site and the way it's laid out. Like, the fact that kids can go online and see where a robot is exploring another world every day, any day they want, hear stories about it and see pictures, is like black magic. Like, it's very, very cool. We're going to do a little Kahoot together, have some fun, folks, and then we'll dive in with questions. I'm so excited for your Mars queries. So I'll bring up our Kahoot together. Abby, you can help us out in the few final seconds of each one of these questions, but we've got some serious like gamers here that have been our all-time Kahoot leaders. So they should be on the ball with all of these questions because they're very good at paying attention. 30 of you so far. Faster you answer, the more points you get. We will dive in, and then I'm going to head to Mr. Shadid's class first for our questions. Here we go. Okay. Such a great program. I just, honestly, my jaw's on the floor the entire time we do sessions together. I love it. 2-1, diving in. Okay, our quiz. Mars is how big compared to the Earth? There was a slide really early on in this that showed a comparison. Is it half as big as the Earth? Is it exactly the same size? Or is it twice as big? I will say this, Abby, I'm pretty sure they have about the same land surface, right?
They do, yeah. If you took all the continents on Earth and smushed them together, it'd be about the same size as Mars.
So it's about half as big. Most of you got that right. As we were just saying, it has about the same land surface, but that's because we have so much ocean. Ocean covers about 70% of the Earth's surface. Venus is actually very similar to the Earth in size. It's a little smaller than us. We're the biggest of the terrestrial planets, yes?
Okay. I think so, yeah.
Cool. All right. Half as big. 21 of you got that right. Let's see where our leaderboard falls. Noble Duck in the lead. Nicely done. And we will go to question 2. Okay. Dun, dun, dun. How many rovers have successfully been to study Mars? These aren't probes around the planet. These aren't things that land and stay there. These are things that drive around and go. And I'm really hoping that my NASA answer I got at the beginning is correct. Is it 1, 5, 20, or 100 plus? Abby, we can talk about this in a second, because I'm pretty sure I got this right. 48, well, nice. So, Abby, it's Sojourner, Spirit, Opportunity, Curiosity, Perseverance. Or is there another?
There's one more that was actually sent from China. There's a Chinese rover that's been exploring Mars, although I think they think the mission has ended. China's not very open all the time about telling their plans, but there are some pictures of the rover you can find online. So yes.
So 6 in theory.
Question. NASA rovers.
The 5 are closest. Most of you got this right. And the big ones, like this is fascinating to me because I was looking up Sojourner before this, and like it made it like 330 feet, whereas Curiosity's gone how far now? How many?
We just passed the 30-kilometer mark.
It's wild. I'm going to show a picture of the mission, how far it's gone, and share it with classes at the end too. But it's unbelievable, the new technological capabilities. Okay, Mars used to have flowing water on its surface. True or false? I hope everybody gets this right. And I will note that this picture, just drawn straight from Kahoot, is literally, I've been there. It's like an hour from my house. It's called the Tablelands in Newfoundland.
Ooh.
So, Abby, if you ever want to come and check out like a Mars analog landscape where the mantle's on the surface and it's really cool, weird rock, come to Newfoundland. We got the best.
Sign me up.
Okay. True, most of you got this right. Yes, Mars and Venus are both really interesting in this way, and that they could have had habitats or ecosystems, not ecosystems, but landscapes and oceans similar to Earth, and they sort of changed over time. They might be they're fascinating to study in their own right and possible warnings for what we might do to the Earth. Amusing Fox takes our lead. As we go to our final question, I just wanted to see what you wanted to answer here. There's no point for this. We will one day walk on Mars. This is like an optimism test. Do you think we're going to? Could that be you or never? No way. We're giving it up. I'm hoping we get a lot of one answer here. We'll see how it goes. 32. Be honest, though. No one's going to check your answer. I'm just curious. I think Abby and I are in the same boat here. Very much. Yes. Very soon. So that's interesting. Okay. About 80%. Over 80% say yes. 11 say no. I think, honestly, the students in these classes might be the age that would be the people that will walk on Mars. Like, that's really exciting, and we're planning for that. And it's a great time to be interested in space. Okay, our winner, and let us know who you are in the chat or in person. Just scream it out. Amusing Fox, way to go. Let's head to our question period. Thank you for that, Abby. That was great. Mr. Shadow's class, Chalk River 678. If you guys want to come on up, you're good to go for our first question. Hey. What are you going to ask, man?
How long have you been interested in Mars and searching about it?
Nice. And I like the Kahoot winner sharing in the background, too.
Yeah, so the question was, how long have I been interested in Mars? I've always been really interested in science, although it was all kinds of science. I loved chemistry. I loved astronomy. I've always really loved space. I watched a lot of Star Trek growing up. But my fascination with Mars, I think, really began with Spirit and Opportunity and them landing and realizing that Mars was like a real place that we could explore in a very way that you could almost touch it and see it. And so that's been about, I guess 20 years now that I've just been really, really into Mars.
The fact that you mentioned that it's a place, I think really you abstractly know there's Saturn out there, there's Neptune, there's Titan, there's Mars, there's Venus, all these places. But like when you see pictures close up or you see a rover on something, it really makes it real. It's quite an astonishing thing to think that there are all these literal other worlds that are close by that we can explore, that we started to explore very seriously. And so I love that question. Thanks, Carter. Miss Cottrell's class, let's head to Baldwinsville. Come on in New York. Hi, fifth graders. Unmute. Come chat with me. Hi.
I was wondering, have you or any of the rovers explored the giant volcano on Mars?
Ooh, yes.
Ooh, good question. Yeah. Mars has the biggest volcano in the entire solar system. It's called Olympus Mons. But no, we haven't sent anything to land on Olympus Mons yet. We've seen it from space, but maybe this is the sort of mission that you could design and work on.
I think that's really what that student's going to go for now. Good knowing Olympus Mons, by the way. And I'm just going to take a brief opportunity to share because it's on the website. Anyone can check this out. Where is Curiosity? And you can dive in and this is like the coolest thing ever. I mean, I've seen some of the things you've shared and links before, but like you scroll in and you see the entire track that Curiosity's taken. You see all these cool little landforms that it's sort of weaved in and out of. Like that is just mind-blowing. I just love it. Anyway, I'll share the link for everyone if you guys want to check that out when you're done.
Yeah, and you can see some of the places we had to make U-turns too. That's
oh God, there's a big wall there. That's funny. I'm going to head to YouTube for a second, and then I'll head back to Mr. Shattuck's class. Miss Nalabako's class wants to know, how long did it take to build the Mars rover? So specifically Curiosity, how many years went into that?
Oh, I don't know the exact number of years. I think they started talking about the idea kind of right around the time Spirit and Opportunity landed, so around 2004. And then the really hardcore designing and building probably took about 3 years, give or take.
You, in the movie Goodnight Oppie, which again, I'm going to encourage everyone to check out when they're done on Amazon Prime, they highlight the building process. And I must say, just getting to talk to you in person about this as opposed to an email, seeing you in a film is really surreal because we've done programs together for years, but it's like, oh my gosh, like she really is like so cool. There she is. Anyway, it's my nerdy note of the day. Let's head back to Mr. Shattuck's class. Come on back in for another question. Hey.
Water on Mars, how would all that water just disappear?
How did it disappear? Good question.
That's a fabulous question, and that's something that we are studying today, and we really want to know the answer to. We have a couple of ideas. We think some of it was lost to space. It was probably in the atmosphere, and the atmosphere has been lost to space. Some of it probably got frozen into ice. And recently we've started realizing that some of it probably actually got sucked up by the rocks themselves, and it formed these minerals that traps water. And we think if we put all this together, maybe we come up with the right amount of water, but it's still pretty unsure. And so that's an active area of research.
I like that you highlighted three things there, because on Earth we have, water gets attached with rocks. It ends up forming sort of water minerals, so to speak. We have things freezing. The idea of an atmosphere disappearing is very alarming. And it's one that we this comparative planetary science allows us to sort of understand what those conditions could be for something like that happening on Earth. And it's distressing, but interesting at the same time. So I'm glad we got that question. Baldwinsville, I'm going to head you guys. We're going to do 3 more questions, folks. And then we're going to let Abby do all our amazing stuff and study Mars. We can't keep her too long. But Baldwinsville, come on back in, New Yorkers.
Hi, my name is Adriana, and I want to know what's your opinion if there's other life out there.
Yes, the alien question. Thank you, Adriana.
Love that question. My science answer is I don't know, and that's why we're looking. But my Abby answer is I just think that there are so many planets that we found so far, and there are millions more we probably haven't found yet. There's got to be one that has life. Like there has to be. So I think there's life out there. We certainly haven't found it yet, but I think we have very good reason to be looking.
I'm going to pull up a picture for a second. And so my wife and I were talking about this the other day, and it's long been said, if we found other life, that might be kind of distressing. Like it might be scary for people. And we both agreed that I think it would be weirder and actually more distressing if there was no other life in the universe. Like if we discovered that we were actually alone, that would be really what happened? But I'll share this picture because it's one of my favorite pictures from the new James Webb Space Telescope on the far right. So this is like if you hold your hand up and pretend you're holding a grain of sand at arm's distance from your face. And we pointed at the James Webb Space Telescope at a thing that was that small compared to the scale of the sky, a grain of sand at arm's length. And every picture, every dot of light in this is not a star, it's a galaxy with like hundreds of billions of stars. So in every tiny little bit of sky this big, there's hundreds of billions of galaxies if you point a telescope at that for the entire sky, many of which, perhaps most of which, have planets. And to think that we're the only life in the universe, I think is very, very cocky of us, very conceited. I think we're likely to find that we are not alone, and hopefully our science allows us to make that discovery within your lifetime. I think it'll be the greatest thing ever found in the history of humanity. Great question. Okay, 2 more questions. I keep waxing mystical, Abby, because I have so much fun with these programs. But I'll get 2 more things asked, and then I'll wrap up with some resources to keep the learning going. So, Mr. Shattuck, come on back. Hi.
Have any of Mars rovers stopped working in their time?
Yeah.
Yeah, so is it have any of the Mars rovers stopped working?
While they're there, like when they keep going, or stop working?
Yeah, unfortunately, yes. So let's see, Pathfinder no longer works. Spirit actually got stuck in the sand, and we were making progress getting it unstuck, but it was a little too late, and that rover used the sun to power it. It had solar panels, and it got stuck in a way that the solar panels were pointed away from the sun, and so it just kind of ran out of energy. Opportunity, there was this big dust storm that encircled the whole planet, and there was so much dust in the air that it blocked out the sunlight, and so that's how Opportunity ran out of power. Curiosity's still going strong. It's been on the surface for 10.5 years, and here's hoping for 10 more, as is Perseverance.
It's quite I mean, I remember when Curiosity landed, like I was old enough, I was super into science, and the fact that it's been over 10 years is shocking to me. For a student, some of our kids are younger than that, so it's like Curiosity is like a historical event to them. Anyway, but yes, ultimately everything that we're going to send to Mars will likely, almost certainly fail. I think we'd be way more shocked if something didn't fail, but Opportunity, and that's where Goodnight Oppie is such a great story. I mean, 90 days, 90 sols, they expected it to last. And it was many, many years. So imagine you buy a car and you expect it to last 10 years and it lasts like 110. Like that would be beyond shocking. And that's the scale of excitement that scientists had with the Mars project. So great question, guys. All right, Ms. Cottrell, I'm heading to you for one final question and we'll wrap up from there. 5th graders, come on in.
If you ever go to Mars, what's the first thing you would explore?
Oh, great question.
Ooh,
No
that's a
pressure.
really good question. It's kind of boring, but I would love to go to Gale Crater where Curiosity is, because I would love to actually walk the path that the rover's driven myself, like, do it like a hiking trail and spend a couple nights camping at some of my favorite sites on Mount Sharp, the mountain that we're climbing. That would just be incredible.
That's a beautiful answer. I like that very much. And to see it, like at some point we get to Mars, we're going to go to the sites where the rovers are, because it'll just be of interest to us. We'll be able to pick up samples, whatever. So it'll be so fascinating. 50 years down the road, we have astronauts that are on Mars and like, hey, this was built, or like my parent built this, or I was involved with this project. And that's going to be the most incredible, incredible experience. Abby, this has been so much fun as always. I do want to encourage, if people want to check out more about Mars in general, follow those blogs, see those latest pictures, mars.nasa.gov. Specifically, you can check out the MSL project, Abby's sort of claim to fame, and then check out what Curiosity's up to. If you want to find out more about her in particular, her career, life story, all this good stuff, check out their unwieldy URL below, or watch Goodnight Oppie. Check out some more stuff there, and follow on YouTube. We've done several programs with Abby, some different focuses in the past. So if you want to head to our YouTube channel, type in her name, you'll see lots more on the go there. Abby, is there a final message for us before we bring in our classes to say a big thank you and farewell about Mars exploration you want to share with us?
Oh, just thank you all so much for your time and your excellent questions. I love being able to talk to you all and share what I think is a super exciting thing that I get to do. And it's fun to see how excited you are too. So thank you so much.
Thank you so much. I'm going to bring in Mr. Shattuck's class. Ms. Cottrell, if you guys want to unmute your mics, we'll wrap up the broadcast in just a second. Thank you so much for being here. Have a wonderful day.